Good morning, children. Let us continue the refractive index, in which we were discussing about the laws of refraction and rules for the refraction of light. Rules means when light ray enters from one medium into another, that is from rarer to denser or denser to rarer, how does the light ray deviate from its path? If it enters from rarer to denser, deviate towards normal. Enters from denser to rarer, deviates away from normal. Then laws of refraction. In that, one important law, Snell's law. It was discussed. Now we'll see one more important concept. Suppose here we take interface. Light ray travels in the first medium, makes an angle I with the normal, that is angle of incidence, and then it enters into the second medium. Here you can see we are deviating the light ray. Actually, if there is no change in medium, it must travel along the straight line. We are deviating the light ray towards normal. So it means 2 must be denser, first must be rare. Okay. Here it makes an angle R. That is angle of refraction. Now in this case, if we write the refractive index of 2 with respect to 1. This is equal to sine I upon sine R. Up to this, I think you are clear. That is using Snell's law. Now, what we are going to do, since this light ray, refracted ray, is traveling in that second medium, on its path, we just place a plane mirror. We just place a plane mirror perpendicular to the light ray. The plane mirror is just placed perpendicular to the refracted. And we know that from the law of reflection, if a light ray strikes a plane mirror perpendicular to its surface, after reflection, definitely it will retrace the same path. So this light ray also retrace the same path, that will it reverts its direction. Now here the light ray is traveling in this direction, and then at this point again it will refract. So it refract and travel along this path. It will retrace the same path because the media, everything is same. What has changed? The direction of light ray is changed. After reflection, if we take the light ray is traveling in the second medium first and enters into first medium. Here it is traveling in this medium and enters into another medium, that is first medium. And it makes an angle R with the normal. Here it makes an angle I with the normal. So here after reflection, if we use the Snell's law, then it will be written as refractive index of 1 with respect to 2. Because in this, the first medium is 2, second medium is 1. So refractive index of first, it enters into first, refractive index of first with respect to second is equal to sine of this angle R upon sine I. Now we got the two equations 1 and 2. If we multiply these two, refractive index of 2 with respect to 1 and 1 with respect to 2 is equal to sine I upon sine R into sine R upon sine I. If we cancel that, this will be 1. So the product of refractive index of second with respect to 1 and first with respect to 2, that is always equal to 1. It is Now, from this relation, we got refractive index of 2 with respect to 1 is the reciprocal of refractive index of 1 with respect to 2. It means the refractive index are reciprocal to each other. Suppose if we take the refractive index of glass that is equal to 3 by 2. Refractive index of glass is 3 by 2. It means what? In this first medium is air because it is the absolute refractive index. Here the light ray is entering from air into glass. If we take the light ray from glass into air, then it will be written as refractive index of air with respect to glass. That is equal to, definitely it will be reciprocal. That is 1 upon 3 upon 2. Now it comes 2 upon 3. So the value are reciprocal if we reverse the direction. And this is one important relation that is known as principle of reversibility of light. Principle of reversibility of light means if a light ray suffers many refraction and at last retrace the same path, then the refractive index is always reciprocal to each other for the given pair of media. That is the principle of reversibility of light. This relation is also for principle of reversibility of light. Reversibility of light, in which we get this relation. Now then, the relative refractive index, it is discussed. By taking these results, these rules, these laws, we can find out how light rays refract through any material. We are using many kind of material. The one material which we are going to use is a glass slab. Glass slab. It is a transparent material in the cuboidal shape. Just we take a transparent material in the cuboidal shape material. If we put that cuboid transparent, that is glass, on this board, if we are able to see only its rectangular face, we are able to see only its rectangular face. It is a transparent material. Here we are going to discuss how the light ray, when it enters from outside into the glass and finally it emerges from the glass also, then how the light ray refract through this glass slab. This is the glass slab. Refraction of light through glass slab. Suppose we take a light ray. It travels, this is air. It travels in air. At this point, it is going to enter into the glass. Since air is rarer than glass, now the light ray is entering into denser medium. If a light ray enters from rarer to denser, it deviates towards normal. If the medium is not changing, definitely it must travel along the straight line. Because of change in medium, it deviates towards normal, so it will deviate in this direction. Now this is the refracted ray. This is the light ray, travels inside the glass slab after the refraction. Then at this point, again it is going to change its medium. Here it is traveling in the glass. After this point, let us take this is the point M, this is the point N. After this point, it is again going to change the medium from glass into air. Now it is entering from denser to rarer, so it deviates away from the normal. Here you see, this is away from normal. In this way, finally the light ray emerged out from the glass slab. So this is the incident ray, refracted ray and emergent ray. Finally it emerged out. And this is angle of incidence, angle of refraction. Here this is also taken as angle of refraction. This is angle of refraction 1, angle of refraction 2. Finally, the light ray emerged from the glass slab, and that's why we say it is angle of emergence. Angle of emergence. Now this is how the light ray is refracting through this glass slab. And if you do this is as experiment. You have this experiment also. You are going to perform this experiment in which we have to show how the light ray is refracting through this glass slab. And ultimately, the light ray is emerging out from the glass slab. While it emerges out from the glass slab, how it is related to the incident ray. This is the incident ray. This is the path of incident ray. This is incident ray and this is emergent ray. While it is emerging out, how it is related? From the experiment, we will observe that the emergent ray is traveling parallel to the incident ray. It is deviated, but still it is traveling parallel to the incident ray. From this experiment, we observe that whenever light ray is refracting through the plane surfaces, it enters from one side and leaves the other side. While it leaves the other side, it will definitely be parallel to the incident ray, but there will be some displacement that we call lateral displacement. The light ray is displaced in the side way that we call lateral displacement. It is laterally displaced from its path. This is the refraction of light through glass slab. Next thing we will discuss in the next class.